Hi, this is Mrs. Dubois to go over practice 10, rate of change and interpreting slope. And we're going to take a slight dab into or dip into whether something is linear or not, whether data is linear or not. Okay, here's the answer, Kay. All right, to, just go back to the foundation of rise over run. We can find slope from 2 points on the graph and then making the triangle and counting the number of blocks up and to be the rise, and then count the number of blocks over to be the run. The very last thing you always want to do is take a look. Do I have a positive or negative slope? And did my answer match what the graph was, positive or negative slope? And the other way that we have seen now is this subtraction fraction. Which is y2 minus y1 over x2 minus x1. And that will give you m, the slope. And then remember that slope should be a reduced fraction or simplified fraction. So now we're going to find slope using the subtraction fraction of 2 points. So let's write up here x1, first x, first y, second x, second y. Then we'll use our subtraction fraction, second y, first y, minus, subtract each other, x to the second minus x to the first, okay? Plug in what we know, 2 minus 5, and then negative 7 minus 4. And keep change opposite. You'll have negative 3 over a negative 11. And the negatives times a negative is a positive. So the answer is slope is 3/11. Example 2, similar format. It gives you 2 ordered pairs, x sub 1, y sub 1, x2, y2. So then the formula, y sub 2 minus y sub 1, x sub 2 minus x sub 1. 4 minus negative 2, and then 6 minus 3. If we keep change opposite, or keep change, we will end up with 6 over 3, which is 2. And you can write it 2 over 1 or 2. Either one, perfectly fine. Just messing around with the colors. Okay, sorry about that. Okay, so now we have x1, first x, first y, second x, second y. So we'll have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that equals 2 minus 4 and 0 minus 1. If we do keep change opposite, keep change opposites, and we'll do it here. So we're doing up there. And the answer, this is negative 2 over negative 1. Again, a negative divided by a negative is a positive 2. Okay, then we have, I'm going to delve into another color. Yeah. We have y sub 2 minus y sub 1, second x minus the first x. $15 minus 3 is 12. 4 minus is 3. You have 4. Simplifies or reduces to 4. In this one, we're going to have the second y minus the first y, second x minus the first x. So we have 2 minus 2. Woo! And 10 minus 1. Interesting. 2 minus 2 is 0. 10 minus 1 is 9. But right there, this 0 in the numerator, the slope is a 0 slope. Okay? All right. Do the last one. Second y minus the first y. Second x minus the first x. 15 minus 3. 15 minus 3. And 8 minus 8 equals 12 over 0. And remember, when 0 is in the denominator, it is undefined. D for denominator, D for undefined. I want to make sure I didn't go too far. Okay, the rate of change is another word that we can use for slope, but it requires you to go down to 1 unit of measurement, like miles per gallon. I knew I was doing that wrong, sorry. So, miles per 1 gallon, right? If you're a babysitter, money per hour. How much money do you make per hour? All right, and so we represent this rate of change or slope in a variety of different ways. You can think about it as rise over run, change in y over the change in x, and then here you have the subtraction. Subtraction fraction. What's your function? See, finding the slope. All right, so the subtraction fraction finds the slope. The table below shows the cost of using a computer at the internet cafe for a given amount of time. Find the rate of change of cost per year. And we've discussed how rate of change is another term for slope. So we're going to pull 2 points from here. I'm just going to take the first and the last point. Okay. So you have 2, 7, and 8, 28, and x1, y1, x2, y2. So it is 28 minus 7 and 8 minus 2. 8 minus 2 is 6. Now it has to be a simplified fraction. So divide each by 3. You get 7 halves, which is how we've been telling you to represent slope. But you do have to consider the situation because it's asking about cost. You don't normally say that something costs 7 over 2 or 7 halves. You'll say like, and when we divide it out, it's $3.50. Okay. So if you want to fill in this tab, this means the cost of the internet cafe, because 350 is positive, and you can see that the numbers go up here, increases by $3.50 with every $1. Because remember, it's 1 unit, so you have to get it down to $1. Now, let's look at this and think about whether this graph of the internet cafe and the points on it would graph out to be linear or non-linear. Well, as you can see, if it's linear, it needs to be constant. And we talked about before, like if you go down the y's here, they increase by 2. If you go down the x's, they increase by 7. So constant constant changes in the x and y determine it to be linear. All right, now we're on trolley buses. The table shows the number of trolley buses in operation in the US during a certain years. Find the rate of change of the number of trolley buses per year for each time interval shown. Complete the sentence frames provided and enter your answer in the answer sheet. All we're doing is finding the slope here and answering this box down here. So from 1995 to 1985, so we take 2 points. We're going to use the subtraction fraction to find, all right? So it's going to be 1980 and 823 buses. And then in 1985, it's 678 buses. Now, right there you can see, if it goes from 825 to 678, it's going to be a decrease. So you're going to come out to a negative slope, or should come out to a negative slope. But let's use our subtraction fraction and subtract 1985 minus 1980. So the bottom will be 5. And then you can either do it on the side or you can use a calculator to compute these numbers. $678 minus 823 negative 145. When I divide that by 8, is that right? 678 minus 823 equals 145. Oh, that's a 5. Gonna divided by 5. So the answer is negative 29. So then we want to fill in these blue boxes, okay? This means the number of trolley buses decreases by 29 buses every year. So that's the labels here. All right. Then we're going to look at the interval from 1985 to 1990. So our points are going to be 1985, comma, 678, and then 1990, 833. Okay. So you'll have 833 minus 678 over 1990 minus 1985. And 830, it should be 823, right? No, 833, sorry. Minus 155 divided by 5-year interval brings you positive 31. All right, so right there you can see that the data kind of goes, down, then up. So if it's positive 31, that means it increases by $31 every, take the label, year. Okay? Now if we stop and discuss, is this data linear? Is there a consistent pattern going down the x's and a consistent pattern going down the y's? No. The data is not consistent. It goes, or it fluctuates, it goes down, then up. And that's the worksheet for today. Thank you.